Hey guys, it's Mr. Terrell, and I want to tell you about the pH scale. Okay, so tell me if there's something that stands out to you, a letter that stands out to you in what I just wrote, that you would say is probably the most important letter when we're talking about acids and bases. Exactly, the H. Why? What does H remind us of? It reminds us of H plus, right? Very, very, very good. Well, the pH scale measures the amount of H plus that's in a solution. A better way to say that is it measures the concentration. I'm going to put that in parentheses. Not sorry, brackets. If you see something inside of brackets in chemistry, it means that you're measuring the concentration of that. You might recall that the concentration would be the moles of H plus, which would be the solute in this case, over the liters of the entire solution. So it measures the amount in a certain volume. Okay? You should remember that. So anytime you see brackets and H plus, you know you're measuring the amount in a certain volume. Okay, so what's the deal with the P here? Why wouldn't we just call this the H plus scale? And that would be so much easier than pH scale. Well, here's why. It has to do with something that happens in regular water at standard temperature and pressure. This is pretty cool. You remember this from previous lessons. You know that water auto ionizes to some degree into H plus and OH minus. Now, here's the thing, how much does it do this? Like in a given glass of water, let's say at standard temperature and pressure, what is the concentration of H plus at standard temperature and pressure? Well, I'll tell you what it is. It's 1 times 10 to the negative 7 moles per liter. And out of curiosity, you might say, well, what's the concentration of the OH minus? Well, think of it this way. You might be sitting there thinking to yourself, you're telling me when I drink a glass of water, I have this strong acid I'm drinking down. And I mean, couldn't that hurt me? What do you think is the concentration of the OH minus if this is the concentration of H plus? Exactly. You don't get hurt when you drink water. And that's because for every H plus, there's an OH minus to neutralize it. So you see this as a double-sided arrow, meaning that every time an H2O forms an H plus and an OH minus, you have an OH minus and an H plus forming an H2O. And this is why, even though these things in high concentrations could harm you in certain situations, in most situations, anytime they're present in equal concentrations, it's neutralized into water. We learned that from a previous lesson as well. So you might be thinking, okay, so what's the deal with the P and the pH scale? Why can't we just have it the H plus scale or the hydronium ion scale or something like that? The reason why is because it's a lot easier to talk about concentrations of H plus in the sense of like a decimal number. Like you really wouldn't want to walk around saying, the other day I had this solution and it was at a 2.45 times 10 to the negative 4 mole per liter concentration. And then I added this substance to it and I found out that it went to a a 1.37 times 10 to the negative 6 mole per liter concentration of whatever, of H plus. You can quickly see how this is not going to really be fun for any lay person that is not a chemist or that is not really into chemistry. When we add P to this scale, what we're doing is P means the negative log. That's what P means here, negative log. So anytime you see P, think of negative log of whatever comes after it. And the H here stands for H plus concentration. So that's what the pH means. This literally is the pH. The negative log of the H plus concentration is the pH. And the pH is the negative log of the H plus. If you take the negative log of 1 times 10 to the negative 7 in your calculator, you're going to get the number 7. Isn't that a lot nicer than 1 times 10 to the negative 7 moles per liter? It's just so much easier to say 7. So this is the reason why the pH scale is the way it is. When we add this negative log aspect to our concentrations of H plus or OH minus, it really cleans things up. And instead of trying to teach a middle school or elementary school student, well, the pH went from this molarity to that or the H plus concentration went from this molarity to that molarity, you can simply say, hey, the pH went from 6 to 3. And then they realize, oh, well, if the number goes down, it's more acidic, and you know that part of it. So what would the pOH be? What would pOH equal for this at this concentration? Correct, the negative log of your OH minus concentration, which would be 7. So the pH equals 7, the pOH equals 7, and for a glass of water at standard temperature and pressure, it's totally neutral, and its pH is 7. Now, we don't really talk about pOH a lot. pH is the thing that everybody wants to talk about because really you can understand either one from the other, and we're going to talk about that more in a second. But just realize that pH is really the place that we're really spending a lot of time focusing on, and for obvious reasons. Okay, so let's talk a little bit more about the pH scale. So now we know that if pH equals the negative log of the H plus concentration, what the negative here means that as my number for pH goes down, as pH goes down, what does that mean in terms of the concentration of my H plus? It increases. So it's opposite. So as the number gets lower, the actual concentration of H plus will increase. So think about this. So if my pH equals 7, that means that my concentration of H plus is 1 times 10 to the negative 7 moles per liter. And let's say my pH goes to 4. This is going to be that my H plus is going to be 1 times 10 to the negative 4 moles per liter. Which one of these is a bigger number, just looking at the numbers? That's correct. This equates to, let's see, 0.0001. 1, 2, 3, 4. And this equates to 0.00000001, I believe. So you see, this is a much smaller amount of moles per liter than this. So do you see how this is more acidic now? How 4 is more acidic than 7? Good. What is the other aspect? Well, the other aspect of the logarithmic scale is that a 1 unit increase or decrease is not simply 1 time greater or 1 time less. When I go from a pH of 7 to a pH of 4, it's not 3 times more acidic for a pH of 4. It's actually, let's see, if I go from 7 to 6 to 5 to 4, from 7 to 6, that's 10 times more acidic. From 6 to 5, that's 10 times more acidic. From 5 to 4, that's 10 times more acidic. So a 3-point decrease in the pH is 10 times 10 times 10 more acidic. 10 times 10 is 100. 100 times 10 is 1,000. So a pH of 4 means the solution is 1,000 times more acidic, which is pretty significant. And that concludes the first part of understanding this, other than how do we go from pH to H plus? Let me just quickly tell you that. You do the opposite function. So to find the H plus from pH, you got to do 10 to the power of negative pH. To find the OH minus concentration, given the POH, you do 10 to the power of negative POH. We'll build on this in a future video. But I hope this was helpful. Mess around in your calculator with these different things and try to convert some H plus concentrations into pH and some pH concentrations into H plus, so on and so forth. And I think that you'll be well on your way to understanding how all of these things work. Anyway, thanks again for your time, and I hope you have a great day. Take care.